So we need to serialize a binary tree, which is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection to be reconstructed later in the same or another computer environment. We need to design an algorithm to serialize or deserialize a binary tree. There is no there is no restriction on how your serialization or deserialization algorithm will work. You just need to ensure that the binary tree can be serialized to a string, and this string can be deserialized. Okay. So what does it mean? Why do we need to serialize and deserialize this binary tree? Pretend we need to send this binary tree like via an API call, and then maybe the backend is gonna operate on this binary tree. We can't just make a post request with the binary tree. Pretend we had the tree node of the root, right? Pretend we had tree node equals root, and this was the binary tree. This was the root of a binary tree, and then under that tree is like a full out binary tree. But it's of type tree node. Imagine we had to make like a post request to a server, like a DFS endpoint, and in the body we had to pass in like a root, and then we just passed in this root. You can't just send a Python class or a Python object via an API call. You need to put it into something like a string, because the language that's consuming it might not even be in Python. It could be in Java, it could be in Go, it could be in something else. So we need to put it in some format that when we send it to the backend or wherever that needs to deserialize it, like it has like a basic format. So it wants us to encode it in a string, so when it sends it over, we can later deserialize it in whatever object you need. So how's this gonna work? We have 1, 2, 3, 4, 5. So basically we need to turn it into a string, and then here we need to decode it and turn it back to a tree. So we just need to put it into some format where we can deserialize it. So let me think. Well, if we're given the root, I mean, I've already done this question before, so I have a sense that we probably need to traverse the tree in some way and store it in either the pre-order, in-order, or post-order traversal. And then we just need to perform that, and then when we deserialize it, we just need to perform that same traversal in order to reconstruct. So pretend we did a pre-order traversal on 1, 2, 3, 4. 1. Let's go like this. Pre-order traversal means we're gonna do 1 first. We're gonna do 1. Pre-order is 1. Then left. So we're gonna do 2. Left. And then we're gonna do 3. Then 4 and 5. But what we need to do is we just need to keep track. We go 1 and then we go 2. Since 2's left child is null, there's nothing, because if we just printed the pre-order traversal, we got 1, 2, 3, 1, 2, 3, 4, and 5. This doesn't tell us anything about the structure of the tree. It could be 1, 2, 3, 4, or like 1, 2, 3, and then 4, 5, like that way. Or it could be, it pretty much 1, 2, 3, 4, 5 doesn't give us the structure of the tree. So we need to figure out, we need to also store the null values. We also need to store the null, or we need to keep track of where the null values are, so we get the full picture of the tree. So if we do 1, 2, when we go left, it's a null, so we could just store that in like a hashtag or whatever. When we go right here, we store that in a hashtag as well. Then finally we go back up, then we go to 3, then 3 we go its left child, we go 4. 4 has left is nothing, its right is nothing. So we go 3, 4. And finally we go up, and then we have 5. And then 5 left child is nothing, right child is nothing. So now this tells us a lot more. It tells us where the null values are if we do a pre-order traversal. And yeah, and then I think pretty much what we need to do is when we just turn this into a string, and that's how we serialize it. When we deserialize it, we just have to do a in-order traversal, or the pre-order traversal again. So what we'll do is, like, we'll turn 1 here. We'll turn this into the root node. So this will turn into 1. And then we pass here. This will turn into 2. This. And then we do a left child. Once we get the left child here, if it's a null, we don't set the left child. Or if it's null, yeah, we just set the left equals to none. If it's null, because, like, okay, I'll also have another pointer at where we are in the tree. Once we have a right here, we'll just put that as null because it's a hashtag. Now since we set the left and right, we need to recurse back up. And now for here, we're setting the right. The right is, so we just need one pointer going along the string here. We just need one pointer going along the string here, and then we'll just be performing the pre-order traversal. But this will be at like the global level here. So, and we could just do a pre-order traversal again. So it's gonna look like this. So we'll just do a pre-order traversal. What's a pre-order traversal? It's like left, right, or it's visit node, then go left, then go right. So what we're gonna do is we're gonna perform a pre-order traversal here. So we're gonna be like, let's do def pre-order self node result. So we'll just put a result here. This is the encoded string, and then eventually we'll return that result. What we're gonna do, pre-order serialize. Pre-order serialize. We'll do pre-order serialize. We'll pass in the root. We'll do some checks first. If root is none, return empty string. Yeah, you're right. Result. So root and then result. We don't really need default here. So what we're gonna do is to do the pre-order. What we're gonna do is, if node is none, we do result dot append a hashtag, and then we return, and then we do a pre-order. So that means we do result dot append node dot value, and then we go left and right. Result or node dot left, or no, we just need to do self dot pre-order here, node dot left, node dot right. return. I mean, there's an implicit return there. So there's a pre-order because we visit the node, then we visit the left, then visit the right. So that gets us this string initially, right here. This one right here. Now we kind of just have to do the deserialization. So if the data is equal to empty string, we just return none. Or empty, wait. Yeah, we just return none. Okay, now we need to do the pre-order, but deserialize. So we'll call it like deser. So what we're gonna be given is we're gonna be given our data in an index. So the data is going to be here, and then the index is gonna be with what number we are on currently, like what number we are in the string. So what we'll do is, wait, let me think about this. Yeah, we just need to return self dot preorder deserialize on the yeah. I don't think we need a node here. We just need the data and the index. Then we'll just pass in the data, but we'll do a split. We'll take the data dot split on the commas, and here we didn't join. We're gonna take the result and we're gonna join all the elements by comma, and then we'll split it here. We'll split it here to get like each node's value there. And then also what we're gonna do is we're just gonna pass in the index as 0. So what we're gonna say is if index is greater than equal to the length of data, or data at index is actually equal to a hashtag, that means we're going to return a null value, because that means it's actually none. Otherwise, what we're going to do is we're going to create a node, and we're going to create that node. We're going to create that node with data at index. Let's see what this is. So for example, we start at data index with 1. So we're going to create the first node with 1. I think all we need to do is return this current node. But we need to do, we need like a global index. Wait, well, because this is 0, 1, 2. Wait, let's see this. Current, something like this. Current. I'll check if we need a global index after that just keeps incrementing. But maybe all we need is current node dot left, current node dot right equals data index plus 1 index plus 2. I think we might need like a global counter that just keeps incrementing. Okay, let's look at this. We create a node 1 like that. Then we recurse on the left child here. Left child goes here. we see that the left child is actually a 2. Oh yeah, we need a global counter because left child here is equal to 2. Like the third and fourth index, like, yeah, because when we passed the right child, we passed in index plus 3. So that doesn't work. So we need sort of what we would do is like, this is a hack right now. So done. Index equals 0. So we wouldn't pass an index here. What we do is self dot index plus equals 1. And then here self dot index plus equals 1. Okay, let's do a dry run. Is that code making sense so far, chat? See if that works. Runtime error. Oh. Oh yeah, we don't even need this anymore. We don't need this anymore. So we need a global counter so that it's always just moving forward here. Because when we're at this 1 right here, if we just pass down like index plus 1, which at the time it's 0, it's going to be pointing at here. But essentially what it needs to do is it needs to skip ahead like this. It needs to know the number of elements in this subtree and skip ahead on this graph. So that way, so we could just have a global counter there. Here, I think all I need to do is, in the pre-order here, I just need to turn this into a string. And here, I just need to turn this into an int. Turn this back into an int. Invalid data return. Wait, let me give me a sec. Print. Oh, it's called tree node. Okay, that worked. Invalid data return. Pre-order. Yeah, but I'm using the global. Oh, sorry. Little bug. Invalid data return. That means I'm not passing the right value in. So, okay, let's just make sure that it's actually so we're taking data and then we're splitting it by comma if the index is greater than the data. Oh my god, you're right. This is why that's why I hate copy and pasting. Did it finally, okay, invalid data. Am I supposed to put it as a string? So how I debug this is like print result. Print result. result.append. Okay, I printed out the tree node. What the heck happened? Okay. Let's just print out this res and just make sure that res looks good. What's the first? Okay, that obviously works. Self.preorder deser, take self.data, and we're doing the deserialize here. Am I even getting here? There's like a weird, there's like probably some, there's probably like a small bug on the deserialization. Let's just look through it. If the data equals this, equals empty, return none. Like, what am I getting here for data? Am I even getting anything? Yo. What's going on? What? Is it even calling deserialize? This is so funny. Okay. Yo, chat, you see the issue or not? Oh, shoot. My bad. Invalid data returned. Oh no, I'm dumb. We need to, sorry, we need to join the result here. Yeah, we don't even, my bad. We just need to join the result here. So we do the pre-order, we pass in the root. That should work better. There you go, there you go, there you go. So now let's just print out, let's actually print out the data here on the first one, and it should match what we have here. Shoot. It should match what we expected, which is this. 1, 2, negative, or 3, 4. Yep, perfect. And then, okay, now all we need to do is return res right here. Holy. So I just messed up that one line in here, like I was doing the return here. Okay, y'all wanna do y'all wanna try out the other one? Let's do this. Let's see. Serialize, and deserialize an N-ary tree. Bro, this one's... Deserialize and serialize an N-ary tree. Okay, this is gonna be fun. Yeah, building that tree is annoying. So we're gonna be, so it's pretty much the same thing. We might be able to just do a pre-order traversal. Take a look at this. We might. That's crazy. No way. So they start with the 1, or we start with the 1. We get 1. Then we go to the left. We get 2. Then maybe we can do like hashtag. Oh no, we can't do hashtags because it's just the children. It's just the children. So we can maybe put a hashtag. That means we need to go backwards. Or 2, 1, 2, that means we need to go backwards. Now we have 3. 3. Then we go 6. 6 is a child. And then we could put a hashtag. Go 3. 7. 11. But how do we know that it's... So now the question I'm asking, how do we know it? How do we mark child versus like sibling? Or pretty much, how do we mark 1, 2, 3, 4? Okay, pretend we do 7, 11, and 14, right? Let's just ignore this half. Let's just try to generate this N-ary tree. Or let's generate this an N-ary tree like this. 2, 3. Like a very simple case. We put the 1 here. Then we put the 2. How do we say the 2 has no children? Do we just go like this? And then we go back up. We go 3. Then we say 3 has no children. Then we have 4. Say 4 has no children. That makes sense maybe. Like we can do the same thing when we do 1. Then we turn this into one of the children. Then since it has no children, we recurse back up. So we build 1. We do 2. It has no children. We recurse back up. Then we have a 3. Okay. What if we had... everyone following along? I'm just playing around with it right now. What if we have 1, 2, 3? So we put 1. We put 2. Then we put 3. Then we put a hashtag. Yeah, I think they're just doing a regular pre-order. Do you think that going from recursion is enough? Yeah, that's enough. Usually you don't have to do it top down or bottom up. So 1, 2, 3. So pretend we had 1. This was encoded as 1, 2, 3. We create 1. Then we create 2. Then we create 3 as a child. Then we create nothing. What if it had a 4? And then create nothing. Then if it was a 4, if it's another number, I think, yeah. Five here, because we get 4 number. Shoot. Then we'd come back, it would be nothing, and then we had 5 number. But I think we need to put another hashtag, which means like if we're Okay, we need to put a hashtag that we're at the end of the level, so we can go back up. So it could be in code like this: 1, we put the 1, then we have the 2, then we have the 3, then we have 3 has nothing, so it goes back up. 4 has nothing, so it goes back up. 5 has nothing, so it goes back up. 2 has nothing, so it goes back up. Finally 1. Okay, so at the end of a level, you just need to mark it with another hashtag. How do I differentiate a hashtag for no child and a hashtag for no more at this level? I don't think you need to. I don't think that matters. For meta, was it 4 mediums? I don't think we need to actually like look at it matters what the hashtag is. We just need to, at the end of the level, just throw in another hashtag. So yeah, let's just go and implement that. Do I need bottom up? Not really, unless they really want you to optimize for space. Usually the bottom ups is when you need to. Nah, I've never been asked a DP question where I need to use a bottom up. So I think we can do a pre-order serialize as well, or pre-order again. So what we're gonna do is we're gonna do if the root is none, at the end, or so we're going to be given a node. Node is none. So what we're going to do is we're going to be given a node in the result. Here we're going to have a result again. We're going to return the result, but we're going to join it up here. We're going to join it with commas. We're going to do producer. We're going to be given root, and we're going to be given the result. If the node is hashtag, we result return result dot append. We result dot append the hashtag result dot append. And we're saying we result dot, at the end of each level, we return we result dot append there, but what we'll do is result dot append the node dot value. That's the node, that's the current node dot value. And then for a child in node dot children, for child in node.children, what we're going to do is self.preorder serialize here, and we're going to pass in the child, and we're going to pass in the result. So that does we're doing a pre-order traversal on an N-ary tree. No, I never interviewed for a quant fund yet. Only like coding assessments and stuff. Result out of pen. Okay. So that deserialize, that serializes it. Let's do this. Return. Yeah, we just need to convert this to a string. 1, 2, 3. Looks good to me. Now we just need to deserialize it. So we need to do similar to this, the pre-order traversal. We're going to be given our data. If data equals empty, we're going to return none. Otherwise, we're going to do self.preorder. We're going to give in our, we're going to say data dot split on commas. Same thing from before. So we're going to be given our data. I'm going to introduce that global index for now, but we're going to we can fix that after. That's an easy thing to fix. We're going to do the same thing where you have a global index so that we can track moving from left to right on here. So if node is none. So let me just remove this code. So now we have the data split up again like this. Like we'll print the data. It should be passed into us but split. Pre-order sort takes two positional, but 3 were given. Wait. Oh yeah. So now it should print out the array twice. Perfect. Now we just need to conduct the if self.index is greater than equal to the length of data, or data self.index is equal to a hashtag. That means it's just a null. Return none. But we do self.index plus equals 1. Now in the data here, what are we going to do? What we're going to do is we're going to create the node. It's called node. We have the code forces guy about to come on, so I need to finish this quick. Self.index. Turn this into an int. Then we do self.index plus equals 1. And then we're going to do the same sort of loop. Or wait. We'll create the thing and we'll do index plus equals 1. Okay, how do I build my children? Yeah, it's like it's pretty much the same. Yeah, I added an extra hashtag. I can fix that global variable. I think all we need to do is just count up the size of the subarray and return it here and then just increment that. But I can fix up the global variable after. But I don't think it will change the algorithm too much. I think the hard part is actually figuring out the children. So while self.index is less than the length of data and think and data self dot index is not equal to hashtag while the index is less than and self dot index and the data is not equal to. Okay, what we're gonna do is current node dot append data current node dot append. What are we gonna append to the current node? We're gonna have to recurse. I'm just doing this for fun right now. Well, like I'm just waiting for the next guy to show up. I'm not unemployed. I have a job. Yeah, don't worry. Let me Plasmatic. Let me finish this quick and then I'll hop on. Oh shoot, I didn't return. So pre-order, sir. If the index is greater than equal to the length of data or the data.index equal to a hashtag, we increment. How am I getting... Node object 1. Print for child in res dot. Okay. 1. We create the 1. We move the index to 2. Okay. We run here. Self. Okay, let's just do a simple case. 1, 2, 3. 1, 2, 3. So if I do 1, 2, 3, we go 1, 2, hashtag, hashtag. Oh, I think I need to do... Okay, wait. 1, 2, hashtag. So mine's like 1, 2, hashtag. Then it goes 3, hashtag. That's the way mine current 1, 2, hashtag. 3, and it would have put the hashtag. Plasmatic, give me a second. I'm just finishing this guy up. 3. So when we do 1, we create 1. Then we increment the pointer here. So since it's 2, we're gonna add a child, which is 2. So it goes here. It's gonna create 2. It's gonna increment index. So that's going to go here. So now we're at 3. It should add a 3 here. Then recurse. Wait, let me add a simple test case. How is this showing? Is this in a pre? One, two, 3. So we do 1. We create the node. Okay, wait. Okay. Once I debug why this is only printing 2, I think it's not this part right here is not generating the children properly. So we have 1, 2, 3, 6, 7. So we have to start with 1. So we'll do 1. We'll go for 2. We'll go 2. 2 doesn't have no children. So this is hashtag. So it should return to 3. Should return to 3. Wow, self.index. Like the thing is, I want to generate a smaller test case and check, but I don't know how they're formatting the tree here. So what do we have? 1, 2, 3. I remember there's supposed to be like a tree viewer. It doesn't even show us. Okay, 1, 2. We got the hashtag. So we go 1, and then we generate the child 2. The hashtag. Oh no, but wait, when we get a hashtag, do we just have to append 2 hashtags? Wait, it might not. We might not need to recurse on a hashtag. If 1, we create 1, we create 2. Then we go to this one. Oh, but we're adding none. What if it's equal to empty? If it's equal to empty. Shit, I can't solve this one, bro. I need some time for this one. Rough. I need to be able to craft up a small test case. I just want to craft up like a 1, 2, and 3. Like how do I create a test case here for that? How does this work? 1, no. Oh, I see. So if I just do 1, 2, 3. Okay, it's separated by no. 6, 7. Let me solve it for this simple case. Plasmatic, almost done. I think if I could solve it for this case, I'm good. Okay, where's the deser? So for the deser, 1, 2. Dude, LeetCode is so annoying. You can't actually look at the tree structure. But okay, that prints out this. We do 1 node. So we pass in the split. We start at index 0. So what we do is we take the current index and then we create the first node 1 and then we increment. Now we're at 2. While self.index is less than the length of data and data is not equal to hashtag, we increment by 2. So we'll create 2 right here. But then we'll be in 2 here. We'll create 2. And now we actually have a hashtag. So we'll go up again if self is not equal to the hashtag. But it is equal to the hashtag. Okay, I think we just need to self.index plus equals 1 here. Let's go! Holy. That one-liner. That one line. Almost got folded. Just this one line. Yo, chat, try out that question. Let me get... Plasmatic, are you in here? Okay. Plasmatic, give me